we're going to prepare our super collider, or we're going to add some code to our super collider code to get the serial data in from our ultrasonic sensor directly into super collider. So we just need to, I showed you earlier how to install the Arduino extension. Now we just need to bring in, we just need to write a little bit of code so that we can read from the serial port. Because remember, our ultrasonic sensor, the thing that's been loaded onto our Arduino, is writing to the serial port. Now we just need to read from that serial port, and we use this Arduino SMS for that. All right, so probably the first thing we're going to do is, let's get rid of this. So we're going to scan our serial port. So we're going to use this serial port.devices. It's a command like that, and so it's just going to tell us the devices that are there, and it gives us basically an array. So I have a Bluetooth modem, Bluetooth PDA sync, and then this our serial tty.usb serial. That is clearly my Arduino. So I'm going to go ahead and copy that. Okay, and so if you downloaded the little packet, the GitHub packet, you'll have this MIDI sign _serial.scd, and it's just an updated, it's basically what we're doing in this tutorial. It's an updated version of the MIDI sign that you were able to play using your mouse, play the sine wave. Now this is going to allow us to also add the functionality of the ultrasonic sensor. Okay, so we're going to create a serial reading object here, basically, and I'm going to just pop back and forth. We're going to go, I'm going to create a global variable. In this case, I'll just call Eno. And then I'm going to say, what is it again? Oops. Arduino SMS. Okay. Use the Arduino SMS object. Okay. And then it's looking for the port name and the baud rate. So we're going to put in quotations that thing we copied from over here in double quotes. And then it's going to look for the baud rate. Well, I remember from my code here, we're starting the serial bus at 19200, 19200. Okay, oops. All right, so that creates, let me make this slightly smaller. That creates an Arduino SMS object. Let's evaluate that. It says Arduino SMS. And then now, if we want to do anything, it's basically, if we're going to use this eno.action. Okay, so every time it gets something's happening on the serial port, basically this is going to go. Okay, so in our case, once every 33 milliseconds. Okay, so if I go ino.action, is it capital? No. Okay, and then you're going to say equals, and then a function. So some sort of function. So whatever, every time an action happens, it will run this function. And it has built-in variables as well, arguments as well. So I guess the first one that comes in is the message. So we're going to have an arg. We're just going to give ourselves a couple of spaces here. I'm going to go arg msg. Okay. And then we'll just post the message, msg.post line. So once we evaluate that, it should come in. I have my sensor here. I don't think I have it on camera at the current moment. It should come here, it should come in. So let me run that. And then you see there, it's coming in directly into my post there as I change my distance. Oops. Okay. So that works good. And then to stop the, you just go, let me remind myself again, .close. ino.close. Okay, so we've confirmed that that's working now. Okay, we've got the right device. So this is just really used once. Once you write your code, you won't need this every time. So that's just the one time to check. Unless you change your device or you add different things, then you'll have to check it, which one it is and what it's called. Okay, but if you're using the same Arduino, it should always be called that. keep our baud rate. So that's just to show you that you can do that. Now we're going to develop our action. So what we want to do is we want to grab in that data that we're sending out from our Arduino, the sensor data. We want to kind of parse it, and then we want to use it in our to change. What we're going to do is we're going to use our ultrasonic sensor to change the volume of our sine wave, to change the amplitude. Okay. So what I need to do is I need to parse that string. You notice here it comes in US1:60. Okay. So what I need to do is I need to grab that 60 away from that US1. It seems complicated in this, seems more than we need to do in this single instance, because we're only using one single sensor. But in future projects, when you're using multiple sensors and they're all coming in at the same time, this will give you an opportunity to index that, to parse that out. So you can use the ultrasonic sensor data for something, and then we're parsing this string and just getting that data out. Yeah, so like if you have multiple sensors, you can parse for a potentiometer or a button or something like that. All right, so it just takes a little bit of massaging there of our data. So our data is actually coming in here in this message, okay, and we posted that, and that's what it looks like, okay. It's coming in a string format because we're posting it as a string, okay. We're just doing something to make sure, okay. So to extract that out of there, I'm going to use this this thing called split. Now let's just have a quick look at what split looks like. If you take a string, okay, and if we, it just evaluates because that's a string. If we do dot split, okay, and then we give it something to split at. Let's see. I don't know if I can do a symbol. Let me try that. No, it doesn't like that. Okay. Well, because of you. Okay, if we split it at the colon, so it tells us what to do really, which is nice. Split, if we go like that, it says it's looking for the separator, and the way it distinguishes, you know, that from something else, that you're actually using it as a separator rather than like a variable or some other kind of thing. You use this money sign, and then my separator is going to be that colon, and it turns green, which is nice. So if I say that, it's going to create an array of strings split by that colon. All right. So if I'm using our actual example, US1 colon, whatever it was, 60. If I split that, it's going to create an array of strings. The first part will be the left of the colon. The right, the second one will be the right of the colon, and the colon just goes away. That's how split strings work. You can do that in processing well. Most programs have this sort of thing. So you can send in a long string, and you can have some kind of delimiter, and then it'll create a index, an array, an index list of all these strings. Okay. So what we're going to do is do that. Then we're going to what did I call it? I think I called it amp. Oh, I have a variable called messages. So var msgs. Okay. And then I'm going to split that messages by that colon. All right. msgs dot split, and then I'm going to do it by the colon. Okay. Messages msgs equals. So messages equals msg dot split. So msg is what's coming in. That's this one that says US1.60. Variable messages is going to be the split version of that split. Okay. And then do I grab it? Okay, no. So let's go ahead and run that. I think we have to restart our Arduino. And if I run the action, it should be, oops. Oh, I'm not printing. Okay. So I think we can just go. And I think I should just rerun this action, and I'll just replace it. There it goes. Okay, see now it's this array that's got US1 in the first bit, and then it's got the second bit is the value. Okay, so then we can of course, extract that if we want. We can just grab the second. Remember, arrays start at 0, index 0. So if you want to grab the second bit of that, let's just rerun the action. And it should just be our data. There's 60. So that's an easy way of sorting out the data. Okay. Now in future posts, when we have more than one kind of data, we might want to divide by another delimiter, but we'll get into that later. Actually, I won't confuse this tutorial with that now. Just explaining how that works. Okay, so that's how we get messages 1, then becomes the pertinent data that we need. Close that as well. Now, just a quick review. I've created a sine wave that has a bunch of different, like an envelope and different things going on. And I have an amplitude variable here, okay? And I've created a control rate argument for the amplitude. We've been over this in the earlier tutorial. So every time I get amp, you can change it, okay? And then, so if you want to change amp, you change it by setting this amplitude. All right, so and then later on I start the synth as this MT, that's the synth, okay, and then what we're going to do is we're going to so it's the synth is already running if we ran all of our code, and then we're just okay. So sorry. Yeah, right. So so yeah, no. So anyways, in this project here, the serial sign, we have the synth def, we're booting everything, and then when we're running the synth going, and so since it's already going, we just have to use our thing to set that synth that's already running. All right, and we're going to set it with this amp message. Okay, so that's what we'll do. We'll get rid of this post line. And then since we already have it, we already have messages, we have that. I like to be very careful here as well, because sometimes data gets confused when transferring between different things. We'll do the as string. We'll make sure that message is a string, even though it should be coming in as a string, because that's what it's printed. And then we're going to change that into an integer. So what we do is then we have this MT, which is our synth that's already running, and we do .set. And hopefully you did enough practice and you know what that means. And we're going to set the amp argument, and we're going to set it to this MSGS. So that's whatever's coming into our sensor. 1, because remember that becomes an array. Too much data there, so we can't go back to it. Becomes an array, and the 0 part is the label US and the S1, and then the second part and the number 2 part is the number. So we're going to do messages 1, and then just to be double clear, we're going to make that .as integer. And that allows us to set the amp. Well, now the problem is it's coming in somewhere between 2 and 60. So that is one issue. So, 60 normally our amplitude range is between 0 and 1, so 60 would be much too loud, cause you to clip and other horrible things. So let's map that data, normalize it between a number between 0 and 1. So you're going to use the range 0 and 60, and then you're going to map that. Okay, so let's create another variable here called amp. All right, and we're going to actually go amp equals MSGS. We're just going to repeat this bit. Messages 1.as integer. Okay, and then we're going to map this here to we're going to do this .lin. It's a linear mapping thing. Let me show you that offline here too as well. So if you want to map something, you can take a number and map it at a range. So if I take 25 and then .lin, Lin just refers that you're mapping linearly from the linear input to a linear output. You also have like lin exp. That's another example. There's a number of those. So it's going to take a linear input and map it to an exponential output. Okay, lin, and then it looks for in min, in max, out min, out max, and there's a clip too. That means that you can set, it to constrain it. So if I go 25 lin from 0 to 100 and from 0 to 1, so it's going to take the number 25, find out where it lies between 0 and 100, and then map that, that percentage between 0 and 1. So you'd expect something like 0.25. And there it is. It comes out 0.25. Okay, so that's how that works. So we're going to map that. So where we're going to map it to? Well, we have that constraint in our code. It's going to go, it has to be constrained from 0 to 60. So it's not going to go below 0. It won't anyways because there's no negative distance. And it's not going to receive an echo before it sent it. So there's never going to be a negative. And then, I don't know, maybe that could happen in like warped space-time or something like that. There was an example of that. I'm trying to remember. Anyways, there's some leading experiment or something, molecules that reality happens before. Anyways. All right. Well, there is this thing that you might have heard of that when people are making decisions of stuff like that, they're, the part of their brain that actually moves to the choice happens before the part of their brain that makes a decision. Anyways, that's something totally different, off topic. So it's going to be constrained between 0 and 60. And then, so we know that it's coming in, whatever this number coming in, it's going to either between 0, we'll make it, it's coming in as an integer, so we'll just make it that, between 0 and 60. Okay, and then we want to map that to a range. We want to do what's called normalize it, which means you take any range and you smush it to a decimal number between 0 and 1. I like to put the decimal point in just in case. Some programs treat them differently unless you put the dots in. Okay, so that's going to be that. And let's just, for fun, let's print that amp. Okay, and I'm just going to comment this out. And I'm going to restart my Arduino. And I'm going to send the action. And then there you go. So now you see, as I'm really close, it's almost 0. As I get further and further away, it becomes closer to 1. Now, you can also, I mean, we won't do it here, but this is a good opportunity here, this little bit here, this mapping bit. You can also use some math and mess around with it, to get a range that's a little bit more a curve. You can multiply it or do some kind of curving so that it more rapidly approaches 1, or goes up more rapidly and then gradually approaches 1. So you can do a lot of interesting things with this sort of mapping. This is an opportunity to do, and that might come in later when you are messing with some sensors. This is an interesting area of interrogation there, to just change that sort of mapping thing into with different algorithms. Okay, so let's get rid of that. So we made our amplitude there. We've mapped this message coming in, and then finally we're just going to set our running synth. It's already running to this amp. Okay, and then that's pretty much it, and that's what we have here essentially. We have, well, we posted it, but we have this 7 and 21. I'm not sure why I did that. I think I wanted a more restricted range there. So, right, because 7, if I put 0, 7 is off. So I didn't want to get actually all the way up to the sensor to turn the amplitude all the way to 0. So in this way, if I get below 7, anywhere below 7, then it will be, well, here it's already been mapped, so you can't see, but it will be 0. And then I guess 21 is as high as I want to go. I think 60 is a little bit too far from the sensor, so I didn't want necessarily that much volume control. And then I'll be 1. So it's a pretty restricted range. Now, if you wanted a much higher one, if you wanted to do something that gives you a little bit more volume control, you can do that a little bit louder. You can just change that maximum. Okay. Then I have this post line and then empty set amp, and that's setting this synth 2 amp. Well, one thing I did change here is I started this synth with trigger 1. That's in this MIDI sign serial. That just means it'll start sounding as soon as you engage it. Okay. Now, finally, I want to just point out, finally, I did make one adjustment to the synth def. Okay. So we're taking in this amplitude. So I am going to, I had just added this one thing. So you'll notice that to the synth def, you'll notice that it's coming in, but if I'm a little bit, if I'm a little bit not so accurate, there's there's jumps in numbers and stuff like that. So what that translates to is you'll get, these volume changes, but you'll get something like goes boo, whoa, whoa, you get these jumps in volume maybe because every once in a while I might move my hand wrong, or you get these random ones every once in a while. Okay, and you don't want that happening. So what I did was I put into the synth def this smoothing filter, this median filter. So basically what it's going to do, and this is already in the original one, it takes in the amplitude, this control rate argument. Okay, so that's going to be this number here between 0 and 1. And then this second bit, this is the new bit I added right here. I use this built-in filter called median, and you can look that up if you want. It'll describe to you what it does and gives you some examples. Okay, and it's a median filter. Essentially, I don't really do statistics or any of this. I think this is pretty basic math, but I can't say I'm qualified to explain this very well. But apparently, the median is it takes the it takes a set of numbers, and then it gives you the median. It gives you the middlemost number. So if you have a string of 5s and then like a 10, it's gonna discard that 10. It just filters that out. So hopefully it filters out these jumps. Okay. Now this number here is the set. So it's gonna wait to take in. Amp is coming in. This is gonna take in 25 at a time, and then pop out the median, and then that'll be the number that gets actually used as your amplitude. Okay, so you can change that number to adjust it. I guess the higher the number is, it adds latency. It makes it a little slower. And then the lower the number is, I guess it's less accurate. So if my blip includes 5 ones, then I want to make sure I have an equal number of things on the other side, that'll counteract those ones. So, anyways, I found 25 works pretty well. So that filters that amplitude, so you don't get those changes in volume, those blips. Okay, so that's one line of code that I added to the MIDI sign synth def. If you're going to want to do that, or you can just use this file, of course, as well. But since we're learning here, it's worthwhile doing that. And then you'll be good to go. So good luck with that. Hopefully that all works for you. Let me just review, actually, really quickly what I did with this Arduino. I activated my Arduino, my serial. Actually, I'm reading from the serial port. It happens to be the Arduino writing to it, but it could be anything writing to the serial port. I've had a serial mouse, for example. I could be reading that data. I use this action equals in this function to bring in, to do something. It performs this action every time it receives a bit of data from the serial port, right? And so I've determined that rate by using this delay 33. So this loop runs, it sends out, prints to the serial port every 33 milliseconds. Okay, so this action happens every 33 milliseconds, whether I want it to or not. So this message is what's the data coming in on the action, on the serial port, what's ever being printed to it. Okay, and then I use these variables to split that message at the delimiter of the colon, because I have this US1 colon. So that splits it into an array. Messages 0 will be US1, and messages 1 will be the number coming in from my sensor. So, and I decide that I'm going to create this variable amp, which is going to take that number. It's a number usually between 0 and 60. It's going to just make sure it's an integer, and then it's going to use this lin-lin mapping system, 0 and 60 to 0 and 1. Now in my MIDI sign serial, I do, what do I do? I do 7 and 21, which is probably what I'd recommend. You can adjust this. So that means that if you want it to be completely silent, like an attack, that's what you have to be below 7. So you can just adjust that. You can make it higher, maybe 9. So then you have a lot more space below, or whatever. 21 is the top. So that depends on how high you want your hand to go. Okay. In this case, I did 0 to 60, which probably isn't the best. And then normalizing that between 0 and 1. And then this action will set mt.set, which is a synth here, that if you engage that, and it will change its amplitude to the amplitude coming in. Okay, so let's give that all a go. I'm going to recompile this, and hopefully that all works. And I'm going to boot my server, and then I'm going to send my synth-def, and it also makes these OSC defs go, and also sends this action going. Okay. Oh, you know what? I think I needed to quit this. Oh, I did recompile. Okay. So that's printing the amp. Okay, good. And then if I send my synth going, there it goes. So it's working. And you notice you can hear the little blips. So maybe my median filter isn't the best, but you can adjust that up here by making the set maybe slightly bigger. It works okay. I think as far as these things go, these sensors, that kind of accuracy is pretty good. Perhaps if you wanted to use a grader, sort of smoother, you can do some massaging, but it might be even better to use a different sensor. If you wanted to get a really, really smooth signal, maybe like an infrared sensor, which uses infrared light. It's the same kind of system, but it uses infrared light to do it. But that's not bad. I'm pretty happy with that anyways. All right. Well, good luck. Hopefully you can get that working for yourself. Yeah.